Hello everyone. Am I audible?
Yes,
Mamadin, were you able to solve questions on extension of determinants?
yes, sir. I was.
Just one question I want to discuss with you guys before we move forward to the next topic. This question where you have to show that. So I'm just taking a simple question. This is a property though. We will be learning today properties of determinants. So at that time we'll be getting why this is happening. But for now, just solve this example and how to solve this. Let's see. I don't know whether you have solved it or not, guys, but just check it once with me. Okay. So the question was if A is equals to if A is equals to 1, 2, 4, 2. Now see, A is a matrix here, right? Can someone tell me what is the difference between this right hand side and left hand side?
Sir, can I see?
Did someone solve it? Please, Madhya, tell me how did you solve it?
So, for the first one, which is determinant of 2a, first we should multiply that whole matrix with 2, and then we have to find its determinant. But for the second one, which is 4 multiplied by the determinant of a, we have to find the determinant of a first, and then we have to multiply 4 with it.
Right, exactly. So in the left hand side, we are trying to find out 2a, the determinant of 2a, right? So 2a is a matrix. So first we'll multiply the matrix by 2, right? And then we'll take the determinant of all of it. And in the right hand side, what we will do is we will find out first determinant of a, and then whatever is that value, we'll multiply that value by 4. Okay. Now we have to show that left hand side is equals to right hand side. So let's start with LHS. So here LHS is 2a, determinant of 2a. So first of all, let us write 2a. So 2a would be multiplying every element by 2. So this would become 2, 4, 8, 4. Okay. Hence, determinant of 2a will become determinant of 2, 4, 8, 4, which will be 4 into 2, 8, minus 32. 8 minus 32 would be minus 24. This is our first equation. And we have tried to find out the LHS of the given question. Now, coming to the RHS. So in RHS, we have to first find out what is our determinant A. Hence, that A will be 1, 2, 4, 2, which would be 2 minus 8, which is minus 6. It implies that 4 times of that A would be 4 times of minus 6, which is again minus 20. So from first and second, determinant of 2a is equals to 4 times determinant of a. So these are some questions. Now we will learn today why is this happening. This is properties of determinant. If you take out 2 outside of the determinant, it will become 2 to the power whatever is the order of that determinant. The order of this determinant was 2. So when you take out any real number like this 2 outside of the determinant, so let's say your A has some value. Let's say A has value 11. And you want to find out what is the value of KA, right? KA. Then you can take this K out, but you have to take the power of K out Which power? Whatever is the order of the given matrix. So if A has order n and that A has value lambda, then K times A will have value K to the power n into lambda. This is a property. We'll learn about it today, but this is the property which is applying here. You can also check the second question. In that, we have to prove that 3A determinant is equals to 27 times determinant of A. Why did we do that? Because the order of the matrix this time is 3. So we will take 3 outside with 3 to the power 3. We'll learn. But such kind of questions are expected in 1 or 2 marks. 2-marker questions, like where you have to prove something based on the properties. So we are done with expansion of determinants. Let's solve one more question on expansion. Do I need to solve one more question or not? First of all, if somebody wants, we can solve one more question. Just raise your hand. Don't worry. Or either chat. Give me a text in chat. If you're not comfortable in raising, it's okay. Don't worry at all. But if you want, I can solve one more question on expansion of determinants, but you should know how to expand a determinant because you'll be expanding determinants. Okay, if you're good with it, then I would like to give you one more question, but this determinant is 4 by 4. This is, but the procedure is exactly same. I would like to tell you. There is, it's not like when we have 4 cross 4 determinant or 5 cross 5 determinant or even 10 cross 10 determinant, then we will be applying some new procedure. No, the procedure is same. The only difference is the calculation will be more. I would like to show you. So, yes, I want every one of you to find out this value. But can someone tell me the procedure first? First of all, along which row or which column we should expand? We can expand it in 8 ways, 4 rows and 4 columns. So we have 8 options to expand this. We know every option is going to give us the same answer, but along which row or which column we should expand this? Okay, and why is that, Maria?
So because we have a 0 there.
Because it contains 1 0.
Yeah, it has 1 0 there.
And I guess row 3 contains 2 zeros. Okay. So we should expand along the row 3. Sorry. Correct, Father. So we should expand it along the 3rd row. Now, just for giving you a hint, don't worry, like don't take this. This is a very big determinant and we would not be able to solve it. No, nothing like that. Okay, so we just have to, first of all, we have to make sure what is the sign. So I'm expanding it along the 3rd row. Okay, so 3rd row would be 3. So delta A would be 3 into cofactor of 3, right? Now cofactor of 3 would be, just delete this column and delete this row. What did you get? This is a 3 cross 3 determinant. You understand it? This is a 3 cross 3 determinant you will get this time. And then to solve that 3 cross 3 determinant, you have to again expand that 3 cross 3 determinant. So basically, your procedure is lengthy. Your procedure did not change. The only thing is that procedure is more calculative this time. So 3 into this element belongs to 3rd row and 1st column. 3rd row and 1st column. So 3 plus 1 is 4. Hence minus 1 to the power 4 would be plus. So I can directly write the minor of it. Minor would be 2, 3, 4. -1, -2, 3. And then 4, 5, 7. Plus 0 into whatever. Plus 2 into. Now this 2 belongs to third row and third column. So third row plus third column is equals to 6. That is -1 to the power 6 would be +1. So 2 into its minor. Again, we will delete this. 1, 2, 4. 0, -1, 3. And then -4, sorry, -5, 4, and 7. With a positive sign only. Because -1 to the power I plus j this time is positive. And then plus 0 into whatever. So in that way, we can find out this one. Just the same procedure. Now we have to calculate this 3 by 3 cross 3 determinant, and I mean 2, 3 cross 3 determinant, and then we will be able to solve this. So please tell me the value. Yeah, guys, whoever came late, we solved one question before, and we are solving second question now. So I want you guys to expand this 4 cross 4 determinant. The procedure is exactly the same, right? The only difference is, I will show you. So I'm expanding this along third row because third row contains 2 zeros, right? Then if I expand it along the third row, so 3 into cofactor of 3. Now cofactor of 3 we can easily find out, -1 to the power I plus j. I plus j in this case would be this particular element belongs to third row and first column. So third row I is equals to 3, j is equals to 1, I plus j would be 4. That is, we will put a plus sign here. There will be a plus sign. Okay? And then the minor of 3, which will be delete its column and delete its row. You will be left with 2, 3, 4, -1, -2, 3, 4, 5, 7. And then again, we will do this for all the other elements as well. The only difference is that this time minor is a 3 cross 3 determinant. When we solve 3 cross 3 determinant, your minor is 2 cross 2 determinant, which can be solved directly. But this time we will have to solve this to get the final answer. And we know how to solve this. We have already done this. So I've just expanded a 4 cross 4 determinant. For your practice purposes, you won't be getting this. Tell me the answer, everyone. Did someone solve the first determinant? 2, 3, 4, -1, -2, 3, 4, 5, 7. Please tell me the answer. फटाफट करो, ये खत्म करके आगे चलिए. ये तो ऐसी प्रैक्टिस पर्पस के लिए. -105. Okay, let me calculate. That is why I wrote it. So this would be 3 into, so 2 into, this would be -14, -15, -29. -3 into this -7, -12 would be -19. Plus 4 into -5 plus 8 would be 3. Maria, you were correct. Yes, this should be the answer. 21. Let me check. 11, not 21. Still, answer should be 11. And then plus 2 into the value of second one is, it's okay. Let's expand it along second row. This 0 into cancel, then this would be -1, and the sign would be plus. Okay, -1 into this 7 plus 20, 27. Then minus of 3 into this charge plus 10. So as I said, it would be, the only difference is that it will be more calculated rather than the approach. We are changing the approach, we are not changing the approach. The only thing is, there is no other approach. I guess that should be the final answer. Did someone confirm me? Did someone get it? Just raise your hand. Okay, please check this, whether it is correct or not, solve it. Okay, but the procedure remains same. If I'm going to solve a 5 cross 5 determinant, then I will also have to go along the same way. The only difference would be minor would be 4 cross 4 determinant. So I'll have to compute a lot. Right. Now, so we have discussed about the introduction to determinants. What are determinants? Determinants are basically a function which receives some matrix as an input and which gives a number as an output. Right? The number can be real or complex. One example for that is that you can write complex entries inside a determinant. For example, this. If you write this determinant, the answer would be complex number. How? 4i plus I, 5i. Right? So to get a complex number, there would be some complex number inside the determinant, and then we will get the complex number. But that is not the thing. This is just to tell you that we can get real number as well as complex number, right? Okay, so the topic for today is, I guess, properties of determinants here. Right? Okay, so there are two important topics from determinants from which you will be getting one question for sure. Okay, and one of them is this, properties of determinants. So we have to apply the properties of determinants over determinants, and then we will have to prove something like that. So all the questions here will be based on proving only. There can be 1 or 2 marker questions on just applying these properties and getting the answer directly. Otherwise, there are higher chances that you will be getting a question of proof from this. But I mean, this has been a trend for a very long time that we get a question from properties of determinant on proof. And you can also check your NCRT as well as your other books. All the questions on properties of determinants are mostly on proof. But first of all, let's understand what are the properties of determinant. So what are we trying to say is that how will a determinant behave? Like, what are the operations on a determinant? Can we add to determinants? Can we subtract to determinants? This is algebra of determinants, right? So right now, we are not talking about algebra of determinant. We want to understand what can we do to a single determinant. Algebra of determinants is not that important. Algebra of matrices were very important. But in case of determinants, we do not follow these mathematical operations on determinants like addition or something. We follow, but this is not in the syllabus. Like, this is, you can understand that later on. You can learn that later on in your undergraduate courses. It has been in the JEE syllabus, but we don't have JEE class. We have only CBSE class. So I will not be teaching algebra of determinants. But if someone wants to understand how is algebra of determinants going on, then I can take an extra class on that. So, but before that, the most important thing is, what can we do with a single determinant? How do we modify a single determinant, right? So that is all about properties of determinants. That what can we do with a single determinant only, first of all. Then we will move on to further, right? Just a second. So it is. Yeah, before we go on to properties of determinant, I also want to discuss one more thing. That I have checked your syllabus for class 12, and I think invertible matrices are there. Invertible matrices there, and also one proof, uniqueness of inverse. Like, if an inverse for a matrix exists, then it is unique. There is only one inverse of a matrix. There are not two inverses of a matrix, right? So this is included, but we will cover that portion in determinants only. Okay. We have covered invertible matrices though. It's not like we haven't discussed about invertible matrices. We have to discuss it again as well, because in determinants we'll be learning how to find out that inverse. Though we will not, we can find out inverse in two ways. First method is eliminated from your syllabus, that elementary row transformation or elementary column transformation. that is reduced. I get, I get it, but invertible matrices is there, and also that proof of uniqueness of inverse that can be asked, right? So these two things we will have to cover, but we will be already covering inverses of matrices again, because without the help of determinant, the second method is with the help of determinant we try to find out A's, right? So first method is deleted, but second method is there in the syllabus. So at that time, just please someone tell me about this proof, okay? If I forget that, I'll cover that proof as well. Yeah, so properties of determinants. So there are various properties of determinants, first of all. Like I can go on and on. There are 15, 20 properties of determinants to get it better. But I think if you know these 4, 5, 6 properties, basically basic properties, then you'll be able to identify all those properties, how they are behaving and why they are behaving. So let's start with first property. First property says that value of a determinant remains unchanged if you interchange rows and columns. What does that mean? If you interchange rows and columns, what is the matrix that you get? If I'm interchanging all the rows with all the columns, then we will get the transpose of the matrix, right? So basically, the first property says that if your consider some matrix A, right, then there will be a value of determinant of A. If that matrix is square, right? If that matrix is square, there will be certain value to that A matrix for determinant. Now, if you take A dash, that is, if you take the transpose of that matrix, the value remains unchanged. The value remains unchanged, totally unchanged, and you can get it very easily. Okay? So first property is determinant of A is equals to determinant of A dash for some square matrix. Okay. And I will try to show you how is this happening. Very simple logic. I'm not going into much mathematical details. I'll only do the proofs which are required, not any extra proofs. You don't need to know proofs. Though if you want to, you can ask me anytime. But strictly for the examination point of view, you will not be getting much proofs. Okay, let's think about this. Why is this A and A dash has same value? Let's say our A is this matrix, some matrix A11, A12, A13. Okay, can I take a 2 cross 2 determinant, because that will be much easier to show you. It is also easy. In that way, I can even show you the values. Let's say this is a matrix. Okay, and I'm trying to find out the determinant of this matrix. So in that case, this will be A11, A12, A21, A22. Now we know the value of this determinant is directly can be find out A11, A22 minus A12 into A21. Right? Now consider A dash. A dash would be your first row, A11, A12 becomes first column, A11, A12, your second row becomes second column. Now let's find out model. See, this is same. Right? And also think about it like this. Let's say you have a 3 cross 3 determinant, right? Now you are trying to find out the determinant, the value for that determinant. So you can expand it along any 3 row and any 3 columns, right? When you exchange rows and columns, still rows becomes columns and columns becomes rows. But if you are trying to expand this determinant along any row or any column, the answer would be same, because the rows and columns are interchanged. because the rows and columns are interchanged. I get it. But in the first case, when you had this 3 cross 3 determinant, let me take this. Let me take some example of 3 cross 3 also. This is 2 that we have shown it, but you get it as soon as later. Okay, consider this A determinant. Okay, I'm expanding it along the first row. Right? When I take A dash, this first row becomes first column. Right? I can also expand that A dash along the first column. If I expand that A dash along the first column and I expand this A along the first row, wouldn't that be same? Yes, same. See, you can expand it along any 3 rows or any 3 columns. So when you interchange rows and columns, that doesn't change the value of the value. This is a very important property that determinant of A is always equal to determinant of A dash. Right? And I have also tried to show you with some mathematical values. This is the first property. Now the second property is, so when you can interchange any 2 rows, and any 2 columns. The sign of the determinant would be minus times. So if any 2 rows, or for that matter columns as well, whatever is happening for rows, that is allowed to happen for columns as well. If any 2 rows or columns are interchanged, in the first case we have interchanged rows and columns. This is light blue. This is also light blue. Okay, if any 2 rows, columns are interchanged, then the value or then the sign of the determinant changes. You can very easily do that as well. Just take any matrix and find out this determinant and then interchange any 2 rows or any 2 columns and then find out the determinant. The value would be negative x. But what I'm trying to say is I would like to tell you this more practically, that what are we doing? How do we apply this app? How do we apply this tool? So the way we are seeing that, let's say we have this determinant delta, which is let's write it in this term: A1, A2, A3. First row is A1, A2, A3. Second row is B1, B2, B3, and third row is C1, C2, C. So what are we saying is you can interchange any 2 rows or any 2 columns, whatever you want to, right? But after interchanging, put a negative sign outside of the determinant. The sign of the determinant will always change. So we are saying that if we interchange any 2 rows, so after applying whatever rows or whatever columns you want to interchange, but not rows with columns, no, not one row will change with one column, no. Either change either take transpose. In that case, all the 3 rows will become all 3 columns of the transpose, right? Or interchange any 2 rows or any 2 columns. Not like you are interchanging one row with one column. That is not possible to do actually. So after applying, let's say I'm interchanging row 1 with row 3. This is the sign for interchange we have discussed about it. So I am interchanging row 1 with row 3. So this becomes minus times first of all, because we have interchanged 2 rows. And then C1, C2, C2, B1, B2, B3, and A1, A2, A3. This is your function. You can again interchange it. Whatever you want to apply. Let's say I am applying C1 gets interchanged with C2. I'm applying one more operation. one more interchange, right? So in that case, then one more negative sign will come, so it will become positive, and this would be C2, B2, A2, C1, B1, A1, and then C3, B3, and A3. The first rule, there's no difference in the value of determinant for a matrix and its transpose. Both have same value. Second rule, we can interchange any two rows or any two columns. Just put a negative sign to before that determinant, right? Then third rule, very easy. If any two rows or columns of a determinant are identical, then the value of the determinant becomes 0. Very easy rule. You will understand. I mean, very easy proof as well. You'll understand why I'm saying this. Okay, so let's say there are two rows which are same in this case. So first of all, what I'm saying is, if there are two rows or two columns of any determinant, however is its order, I don't care about order. If in that determinant there are two rows which are identical or there are two columns which are identical, the value of the determinant is 0. Why? So I'm interchanging here row 1 and row 2. I have learned it in the second part that if I can interchange any two rows or any two columns of the determinant, right? I can do that. But after doing that, I will have to put a negative sign. I will have to put a negative sign before that determinant. So I'm applying row 1 interchanged with row 2. Right? Okay, so this was delta. Now I am again I'm interchanging row 1 with row 2, so I'll have to put a negative sign. Correct? Then it would be now first row and second row when interchanged, you are getting the same determinant. You interchanged row 1 and row 2, but the answer of the determinant is still same. No. Now understand this. First determinant and second determinant both are same. When you interchange row 1 with row 2, there is no difference. Now we are saying that in first case, this determinant holds a value delta. Correct? In the second case, the same determinant, if I multiply both sides by negative, then in the second case, that same determinant holds the value minus delta. Correct? You can multiply both sides minus. So you can write this as that A1, A2, A3, then again A1, A2, A3, and then here B1, B2, B3 is equals to minus delta, right? So this is your first, and this is your second. So can I say from first and second, delta should be equal to minus delta? I mean, if you interchange two rows, the value must be same because they are both the same determinants. So one is giving delta, another is giving minus delta. So delta should be equal to minus delta, which means 2 delta is equals to 0, which means delta is equals to 0. Hence, hence, whenever you see any two rows or any two columns of a determinant are identical, just put that value 0 directly using this property. You don't need to solve that. So how can we use that? Let's say I have seen 1, 2, 3. Okay, 1, 2, 3, and this is 4, 5, 6. I can directly say the value is 0 because first row and second row is same. That is how I can use it. Right? Now the fourth rule. Also an important rule. Important was everyone. Every rule was important. But this will hold a higher significance because we will be using this a lot. Now what are we saying? You can understand it in two ways. Let me try the first way first. Then we will talk. Let me try the how book wants to understand this, how book want you to understand this, and then I'll tell you my interpretation. Okay. So they are saying that if each element of a row then the value of the determinant gets multiplied by k. We can prove it very easily mathematically. Take any take any example. You can take this. Let's take a 2 cross 2 determinant. So this is A1, A2, and this is B1, B2. Now first understand what we are saying. We are saying that if you multiply any row or any column of a determinant with same constant, then the value of the determinant becomes that times whatever you have multiplied, that times of the original determinant. So understand this first. We are saying that if delta is equals to this, and let's say we want to find out Ka1, Ka2, B1, B2. That first row is multiplied by the same element K. Then we are saying don't calculate it. Don't. You can directly write as K times delta. But let's understand this because we are solving this, so we can solve this. So this is Ka1, B1. And you also know that value of delta here is A1, B2 minus B1, B2, right? Now, in this case, this will become K A1, B2 minus K A2, B1, right? Which is nothing but K times A1, B2 minus B2, A1, which is nothing but delta. No. This is nothing but delta. So if you multiply one row or one column of a determinant by some number, then the value of the whole determinant gets multiplied by that number. Now, my interpretation from this is we can take common. Okay. So how was scalar multiplication happening? How was scalar multiplication happening in case of matrix? So let's say if I multiply a matrix by a number, then what do? We multiply each element of that matrix by that number, right? We multiply each element of that matrix by that number. But that is not the rule in case of determinants. So if you want to multiply a determinant with some number, right? So let's understand this another explanation. So if I'm writing this a times of a1, a2, b1, b2, right? Then I can take this k inside with any row or any column, but with only one row and one column. I will not multiply this k with each of the element inside the determinant. No, which was the case in case of matrix, right? In case of matrix, we multiply this, we take this number inside and we multiply each and every element with that number. But in case of determinants, no. You will only take this inside with one row or one column. That is your choice, which row, which column are you choosing. We don't have any say in that. Use it accordingly, use it wisely, we would say. Wherever you want it, use it that way. But there is no rule that you have to multiply this with first row, first column, second column, whatever way you want to go into it. So if I take this k inside, this will get multiplied either with first row, second row will be same, no change, or with second row, then first row will remain same, or with first column for that matter. Or with second column. All are same, everything is same. But always remember, we can only take this constant inside with one row or one column. Whatever row or whatever column you choose, that is up to you. Which also means, I'm coming to the third interpretation now, which also means if I want to take common from a determinant, don't write it. Listen to me, this is an important rule. So if I want to take common inside the determinant, right? If I want to take common from the inside of a determinant, I can take common from either a row or a column. Like in case of matrix, if I want to take common, I'll have to take common from every row. Just listen to what I'm saying. We'll say this is a matrix. I will show you both equations. Matrix, in case of matrix and in case of determinant, this operation is different. Yes, you can also do that, Maria. But you want the way to use this is like this. That is what I'm trying to. You won't be able, I mean, they won't say to you that find out this value and then prove it. No. You will get it, what I'm saying, in a way. Okay. But yes, you can do that, whatever you are saying. You can do that. But they won't give you the chance to do that. Let's understand what I'm saying in a bit when we move on to the questions. So, I'm trying to take an example here. So, in case of matrix, let's say this is 2, this is 3, this is 4, and this is 6. And I want to take 2 common outside of the matrix. I want to take 2 common from the matrix. Then I can take it. But inside will be 1. This would be 3 by 2. This would be 2. This would be 3. So that if I multiply this 2 inside, this becomes 0. Because in case of matrix, this number will get multiplied with each and every element, right? But in case of determinants, no, this is not the case. See, so in case of determinants, let's say I have this. I can take anything common, whatever I want to take common. That is, I mean, I will obviously divide every element with that, not every element. But whatever I take common, that will be taken common from either one row or one column. So I'm taking common from second column. Okay. And what I'm taking common is 2. So I can take 2 common. This first row becomes, so the first column is 0, and second column becomes 1 and 3. So the another implication is how to take common. How to take common in case of determinants. In case of determinants, you only take common from either a row or a column. You can take multiple commons. I'm not saying, I'm not denying that. But to take anything common, you will only use one row or one column. Like, for example, I can take 3 common from second row. There is no 3, I know. Don't worry. There's no 3. But I can take 3 common from second row. How? So let's say I'm taking 3 common from this. So 3 is outside. So 3 into 2 is 6. Right? Now this is 1. This is 1. This is exactly the same because we are taking common from second row. Right? Now the second row becomes 4 by 3 because you have taken 3 from here and there was no 3. Right? So you have to divide this by 3. And 3 was there, so it becomes 1. So you can take common from just a row or just a column. While in case of matrix, you will take common from each element because the rule is same. Scalar multiplication in matrix is to multiply each and every element with that scalar. But in case of determinants, the scalar multiplication is just multiply that with one row or one column. Similarly, if you want to take common, just take one row or one column and take whatever you want to take common. हाँ जी, क्लियर है ये बात? जितने भी हिंदी भाषी लोग हैं मैं उनको बताना चाहता हूँ कि बस बहुत सिंपल सी बात है, कॉमन लेते हैं मैट्रिक्स में तो हर एलिमेंट से कॉमन निकालना पड़ता है। सिमिलर टू कि अगर आप मल्टीप्लाई भी करने जा रहे हो कुछ तो हर एलिमेंट को मल्टीप्लाई भी करना पड़ेगा। बट इन केस ऑफ डिटरमिनेंट्स आप कॉमन लेना चाहते हैं, किसी भी एक रो से पकड़ के कॉमन ले लीजिए, किसी भी एक कॉलम को पकड़ के कॉमन ले लीजिए। सिमिलरली जब आपको स्केलर मल्टीप्लिकेशन करना चाहते हैं डिटरमिनेंट्स के साथ, तो आपको सिर्फ एक रो या एक कॉलम किसी भी जो आपकी मर्जी उसमें जाके मल्टीप्लाई करने का है। ऐसे नहीं कि हर एलिमेंट को आप मल्टीप्लाई कर दो, ठीक है। एंड दिस इज एग्जैक्टली द प्रॉपर्टी जो अभी हम डिस्कस करके आए, जो आपने प्रूव किया। I told you at that time that if you take common in case of determinants, this becomes k to the power n. A to the power n. That is the same property based on this result only. Okay. I would like to write this. I would like to write this like this. One row or any one column of a given data. Right? Okay. Let's find out this value. So I'm writing this as delta 1. Wait a minute. Okay, first of all, expand. We're going to expand this. No. So, Madhya, what I was trying to say before when you asked that question, we know how to expand a determinant, right? and by expansion of determinant, we can find out the value of that determinant. But in
Yes.
this particular exercise, you will be explicitly told not to apply extension of determinants.
Mm,
What does
okay.
that mean? You cannot expand the determinant. No,
We can't expand.
you will not have to expand the determinant, and you have to find the value of that determinant using these properties only. Using these
Okay, sir.
properties only. You don't expand the determinant now.
All
Okay.
right, sir. Yes.
So now in these two cases, if you are finding out the answer by expanding them, no use. We haven't learned anything in the class then. I want you to solve them using these properties. Can we apply some property for question number 1?
So we can take common.
Maria, I'm not able to listen to you. Please speak.
So can we take common?
Yes. And what should we take common?
So we can take any number as common, right? Like we can take 3 as common for the
Okay.
first row.
Will that help us? We can do a lot of things because we are learning these properties, so we can apply these 5-6 properties anywhere. But the point is, after applying that property, what did we get? What is, I mean, you have to think about the next step always in this particular case.
So can we take 0 common?
Yeah. How would you take 0 common? Okay. First of all,
Okay.
take 0 common
Okay,
from
no.
this. No, we
Okay, no,
can't.
no.
We
We
actually
can.
can, but you'll have to show me the procedure. Okay.
So that
So
will be not defined for every other number then. Yeah.
if you take 0 common, that would be 4 by 0 plus 7 by 0. You don't want to make 0 in the denominator. In fact, that is the only rule I would like to tell you, that you can't, you can never, you will always try to not form a 0 in the denominator.
Yes.
This has some property. All of these are not, we don't need to expand them, certainly.
So it is 0.
Why?
The 2 columns are same.
Yes.
So
Column 1 and column 3 are same.
yeah.
So in this case, so every question which I will give you right now will be based on these properties only. And these are for 1 mark of questions. Like you can get a question like this, and you have to find out the value of that determinant, or maybe to apply some property of determinant. I'll give you some more questions like this, in which you have to apply these properties, and these will be easy to understand and very quick to. I mean, you guys have to be really quick to solve them, because you just have to apply the properties. You'll be good with it once you apply some questions, but this will take time. Today you will be getting a lot of homework as well. Please put that into work during this whole week. Okay, so first one is 0, right? Because C1 and C3 are same. Now the second one. We can certainly take common. Mamudi. Fahad. No, I want to ask you something other than this. Now the question. Is Fahad in the class? Yes. Fahad, what's the time at UAE right now? I mean, are you guys having a problem with managing iftar with classes? If yes, please let me know. We'll try to. Cool. वैसे तो ऑनलाइन ही क्लास है तो you can eat. I don't have a problem. In my class, you can eat whatever you want to do. But just you have to be present. You have to focus here. You eat. Don't play games. You eat. I don't have any problem with that. do whatever you want to do, but you have to focus here. Whatever you can do by not losing your focus in the class, you can do. Okay, second part. 246369 minus 246. बहुत टफ है, हुआ नहीं कभी इससे, आज तक नहीं किया किसी ने क्वेश्चन, काफी टफ. क्या 1 घंटा लोगे इस पे करेंगे? और ऑस्टिन, आई एम जस्ट प्लेइंग विद देम नाउ.
Yes, yes.
Faiza, what can we take common here?
Sir, the first row.
What from the first row?
2.
2. What will be the first row after taking 2 common?
1, 2, and 3.
Correct. Can we take common from second row as well?
Yes, sir.
What?
3.
And
1,
what
2,
will be
and
the second row?
1, 2, 3.
So can you tell me the answer now? Okay, take 2 common from the first row and take 3 common from the second row. So 2 into 3 outside will be 6. Now this will become 1, 2, 3. This will become 1, 2, 3. This will become minus, and we can also take minus 2 common from, or 2, whatever. I'm also taking 2 common from this. This becomes 12. 2 from first row, 3 from second row, 2 from third row. This becomes 2 into 3 into 2, which becomes 12. And this is minus 1, 2, and 3. What's the answer of this? Price only. You can tell me. Isn't the answer 0 because the row 1 and row 2 is same?
Yes, sir. It's 12 to 0, 0.
0. So most of the questions I'll be giving you will have answer 0 only. I mean, like these type of questions. They may have some other answers as well. I'm not saying that, but when you want to solve the determinant with some values, right, and without expansion, you are told to do so. Then in most of the cases, you will have to use the properties, and the answer will be mostly 0. I'm not saying 90%, 9 out of 10 questions will be getting answer 0. In one question, you will get answer 0. Right? But these are only 1 or 2 mark questions. Okay. Okay. Let's move forward and go to what? 5th property. So you understood 4th one. You can multiply. Scalar multiplication in determinants works like you have to multiply the scalar either with 1 row or 1 column. Similarly, taking common is also working. Taking common also works the same. You can take common from either 1 row or 1 column. Right? Okay. So let's see this 5th property. Yeah. This one. This one. Like you to observe here. In the second question. Okay. Let's observe first row and second row. In the first place, when I saw these 2 rows, they were not same, right? 2, 4, 6, and 3, 6, 9. And the third row is minus 2, 4, and 6. That is also not the same with row 1. But still the answer is 0. Rows are not identical. In the first site, rows were not identical. Neither any row or any column were identical for that one. Right? But after taking some common, we saw that 2 rows are identical and the answer is 0. So can we also get a determinant as 0? I mean, can we also get the value of a determinant 0 if 2 rows or two columns are not identical? Yes. There are multiple, there are multiple determinants in which there is no two row or no two columns are same and they have the value 0. That can happen, right? But also, the value will always be 0. The value is always 0 when two rows and two columns are identical. First rule is this. Second rule is also there, that if two rows and two columns are identical, are proportional. Proportional meaning they are in same proportion. So let's take first and second row here. Okay. The first proportion is 2 by 3. In this, the first proportion is, I'm taking these two rows. First proportion is 2 by 3. Second is 4 by 6, which is again 2 by 3. Then third is 6 by 9, which is again 2 by 3. So can we say that R1 divided by R2 or rather, sorry, not like that. R1 can be, you can get 2, 4, 6 using this 3, 6, 9, right? How? This is R1 is equals to 2 by 3 of R2. And we can say that R1 by R2 ratio is 2 by 3. So you can also say that the rule is this. If two rows, obviously when I say rows, you always write this columns. The rule is same for rows and columns. If two rows or columns are proportional, that is, they have same proportion throughout all the elements, then the value of that determinant is also 0. Because if you take common, then they both will become 0. This is your fourth rule. Now the fifth rule. Fifth rule is based on how to add two determinants. Fifth rule is how to add two determinants. So rather than writing it whole, I would like to show you. I would like to make you understand how can we add two determinants or how can we subtract two determinants. Both will work exactly the same. And multiplication of determinants works exactly the multiplication of matrices. The only difference is in matrices you multiply the rows of first column with columns of second. The rows of first matrix to the columns of second matrix, right? You take first row from first matrix, then multiply it with every column of second matrix. Then you take second row from first matrix, then multiply it with each and every column of second matrix, right? That is what we did in matrices. But in case of determinants, you can either multiply row with row. The order has to be same. You can only multiply a 3 cross 3 determinant with another 3 cross 3 determinant. Not like one is of order 3 and another is of order 2. You cannot multiply them. If the order is same, then you can multiply them in any way you want. Either row with row, row with column, column with row, column with column. All the 4 operations are possible. That is the only difference. You won't need it. This is just for your knowledge part. You won't need it. There is no multiplication of determinant in your syllabus. But how do we do that? This is the way to do it. Okay. In maybe 1 or 2 questions you will need it, but not much. Okay. But multiplication of determinants will be done exactly like matrices. But the only difference is you can take either row or column from the first matrix, and similarly either row or column from the second matrix. You multiply row with row, you multiply row with column, column with row, column with column, all as right. Okay. So fifth rule is how to add two determinants. Now, listen it very carefully. Okay? We can only add. We can only add two determinants, or we can only subtract two determinants when there are any two rows or any two columns of those determinants are identical. What I'm trying to say is, let's say I have this determinant and I want to add this with this determinant. No, I can't. Can't. You cannot add two determinants directly. Yes, you can do that. You can take, you can solve the first determinant as well as solve the second determinant and then find out the final answer. That is okay. But if you're writing it like this, that this becomes 6, 8, 10, and 12. No. No. Can't add two determinants directly. Or for that matter, you can't subtract two determinants directly. No. There is a rule. What is the rule? That let's say, if you want to add two 2 cross 2 determinant, the order of this determinant is 2. Also, the order of this determinant is 2. Now, if you want to add them, these are only addable, or they can only be added if either one row or one column of both these determinants are same. If either one row or one column of both these determinants are same, that is, either first column has to be equal to first column, or second column has to be equal to second column, or first row has to be equal to first row, or second row has to be equal to second row. Out of these 4, one must be there. One must be there. Right? Now, for adding two determinants of order 3, let's say we have order 3 determinant. How do we add them? For adding them, we need any 2 rows or any 2 columns to be identical. So what does that mean? We can basically add one row with one row or one column with one column in determinants. And that is true when both the other rows or columns are same for each determinant. So in simpler words, I would be writing this example again, but first of all, I would write the rule. So if you want to add, so let's say this is lambda 1, lambda 2, lambda 3, then this is A1, A2, A3, and then this is B1, B2, B3. And you are adding or subtracting. Addition and subtraction both are same. I mean, what is subtraction? Minus 1 times addition. Have you learned all the formulae for positive and negative separately? Like a plus b whole square is a square plus b square plus 2ab. So did you need to learn a minus b whole square separately? We don't. Any formula for addition is applicable for subtraction as well. We have discussed it in class 11th and various times. That all the formulae for addition and subtraction are same. Just change that subtraction to plus of minus 1. Right? Okay. Now let's come to this. See, 2 rows are same. R2 and R3 are same for both of them. Then only I can add or subtract. If this is of 3 cross 3, obviously. If this was 2 cross 2, then one row or one column has to be same. So now how I am going to do that? Simple. Just perform the action, just perform that operation on the different rows. So this will become, if we are adding them, this will become plus. If we are subtracting them, this will become minus. And this is similar, A1. This remains same. No change in this. No change. This is lambda 1, lambda 2, lambda 3, A1, A2, A3, then B1, B2, B3, we are adding or subtracting with another determinant, then the first rule is we can only add or subtract if there are two rows or two columns are same. Any column, it can be any column, it can be any row, but two rows and two columns must be same. And then perform, then whatever is the same, you take that as it is, and whatever is different, you perform the operation on that row or column. Right? So, did you understand it? If you do, then I would like to check that. How? So, obviously, the reverse operation is also same. If you get a determinant, okay, let hear out. Just hear out this explanation as well. If I get this RHS determinant in which there is one row or one column which is specified in a sum of two. So in this, the first row is specified in the sum of two, lambda1 plus k1 or lambda1 minus k1. Then I can go reverse. I will only break one row or one column at a time. Other two rows and other two columns will be same. Right? So I will only break this first row. Other two rows are same. And I'll break this first row as lambda1, lambda2, lambda3 in one column. In one determinant. And then k1, k2, k3 in another determinant. So two determinants can only be added or subtracted if they have only one row or column. It can be anything. And G, guys, did you understand this? If you did, then please help me out with this property. Let's hear me out first. This is E. Don't get confused in E and C. Now, what I'm trying to do is I'm trying to break this determinant. Okay. So how can I break this? If I want to break this, I will have to take two rows or two columns exactly the same. Two rows or two columns exactly the same. And one row I can break. So I'm breaking first row. I'm breaking first row. So I can write it as this will be A1, A2, A3 plus this would become D1, D2, D3, and rest of the determinant will be same for both of them, as was the original determinant. So this would become B1 plus E1, B2 plus E2, and then B3 plus E3, and this will be C1, C2, C3. This will be again B1 plus E1, B2 plus E2, B3 plus E3, and this would be C1, C2, C3. You have this choice that either you want to break first row first or second row first. Bilkul doable, no worries. You could have you could have broke the second row, right? That doesn't change the value of the determinant. But whatever row you break, you will have to, or whatever column you break, you will have to take another rows or columns as constant for both of the determinants, right? Now we can further break this. Can further break this into two. And again, we can further break this into two. No. So this would become what? A1, A2, A3, then B1, B2, B3, then C1, C2, C3. Plus, this would be A1, A2, A3. Now this will be E1, E2, E3. And this will be C1, C2, C3. You can see that I have broken this into two parts, but two rows are same. And then similarly, this would be D1, D2, D3. Then this would be B1, B2, B3. And this would be C1, C2, C3. Plus, this would become D1, D2, D3. This would be E1, E2, E3. And this would be C1, C2, C3. Guys, did you understand this property? No. If no, please raise your hand or text me, whichever way you are comfortable. Cannot write it directly. Yes, Madhya, we will have to break this till we don't have any row or any column which can be expressed as the sum of two numbers or two elements. We will keep breaking this, right? Okay, I'll have another question for you guys. See, in this case, when we broke this, finally we get four determinants, right? So I have two questions from you. The class is over for now. We are just left with one property. We'll solve that in the next class. And you will have to apply a lot of questions, but before that, you will have also need to solve some questions with me. Okay. I'll send assignment. Don't worry. You just try to solve examples before 4.2. Okay. I'll check whether we have some questions in assignment or not. But I have two questions for you before that. First of all, let's call this one as 1, 2, 3, 4. Okay. Can I add second and 4? Can I add second and fourth here? Are they addable? I mean, can they be
Yes, sir.
added? Why?
So because two rows are same there.
Row 2 and row 3 for both of them are same. Can we add first and fourth?
No, no, sir, we
No.
can't.
But there's only one row here, right? Okay, so this was my first question, that you should understand when can we add two determinants or when can we subtract two determinants. Now the second question is, what if I write this determinant as now? Can you tell me how many determinants will be formed so that there is no row or no column containing the sum of two numbers? और मोटी मोटी भाषा में बोलूं तो इसको बस तोड़ के छोटा छोटा लिखना है, हर बार एक ही एक नंबर होना चाहिए, जैसे अभी आपने किया है. The same way which you have done, what would be the number of determinants, different determinants for this? Like in the previous case, there are 4 determinants in which you can break that. sum of 4 determinants. In this case, how many determinants will be there? Now you give me this answer, and by that time I will find out the questions for your assignment. Yeah, you know, iski zarurat nahi hai. You don't need that question. You already know the question. If not, I will tell you the question. I mean, every row has sum of 2. Okay, so the your homework is, first of all, first 21 questions. First 21 questions from the assignment. First 21 questions from the assignment. We are taking every question. First 21 questions. And then 7th. Try to solve it. Okay, first 21 and then this 7. Yeah, how many determinants will be there if I write it like this? 8. Because see, this will be also in F1, F2. So what happens? In all of these 4, you get the C1 plus F1, then also C1 plus F1, then also C1 plus F1, and then also C1 plus F1, right? All of them contain this. And then after these 4, after you get these 4, you'll have to break every one of them into 2 more. So there are total 8. No? Solve it. You did not understand it, try to solve it yourself. And if you still did not understand it, please help me. I'll solve this for you. Okay. Shahir, please start with your test. We are done for today. And we'll be covering the last property of determinant in the next class. By the time you solve these first 21 questions and also question number 7. First 21 questions from the assignment, and then after that 21, next question number 7. Okay, you got 22 questions from here, and as well as examples of, check out all the examples of NCERT. Okay, you really need to do these. If you want, you will be, these 4 marks are confirmed. But this has been a trend that you will get a question from you. Okay, so we'll meet next Saturday.